Okay, so now we're going to do a few complex fractions, which are very well named, I like to say, because they are complex and they obviously are fractions. So there's a few ways you can do these. They normally teach you two different methods. The one works really well if you already have one fraction in the top and one fraction in the bottom, which is what we have here. So I'll go ahead and use the first method on this problem, which is to simply rewrite it as a multiplication problem, because like we talked about earlier, dividing is always the same as multiplying by the reciprocal. Okay, but this only works when you already have one fraction in the top and one fraction in the bottom. Okay, but when you do, it's really not that bad of a problem because you're really just dividing, which is like multiplying by the reciprocal. So are you with me so far?
Yes.
Okay, now you can do what we did earlier. See if anything cancels. So do you see anything that cancels out?
Yes, the 4 and the 16.
Mm-hmm. So what does it become?
The 4 cancels out and the numerator is a 4.
Good. We divided each of them by 4. So this becomes a 1, which basically cancels out. Good. Okay, so then what is your final answer?
So it's x plus 2 over 5x minus 1.
What did you forget?
Oh, the 4.
Mm-hmm.
So I can distribute that though, can I? So it'd
You
be
can
4x.
distribute it or leave it like this. So yeah, 4x plus 8, or you can just leave it like that.
Okay.
Mm-hmm. But you certainly need to include it there.
Okay.
Mm-hmm. Okay, so that's the best way to solve it when you just have one fraction in the top, one fraction in the bottom. However, sometimes you have multiple fractions in the top and multiple fractions in the bottom, like in the next problem. When that happens, I like to use the second method, which is to clear out everything by multiplying each term by the little LCD. So you want to look at all of your little fractions, which you have 4 of them, right? And look at their denominators and figure out what the LCD is. So you have x, x minus 1, x, and x minus 1. So what is your overall LCD for your 4 little denominators?
It would be x times x minus 1.
Good. Now I want to show you why this works, and then I'll kind of show you how I actually apply it. So you're really just multiplying top and bottom of the whole thing by x, x minus 1, which is mathematically valid, right? Because you're really just multiplying by 1, right? Mm-hmm. But what that happens when you distribute that is it's really like you're multiplying that to every single little fraction. But that's why it actually works. So I'm going to rewrite it, even though it's a pain. X minus 3 over x. And then that's going to get multiplied by x, x minus 1. Oh, I don't like, do you see how there's a minus, a negative 8?
Yeah.
I'm going to change that to plus 8 because there's no need to have a double negative if that's okay with you.
Okay.
Because that's just messy otherwise. But I'm just rewriting it and then multiplying each little fraction by x, x minus 1. Okay, so for the first little fraction, what cancels out?
The x.
Mm-hmm. Okay, so that leaves us with x minus 3 times x minus 1, which we're going to have to work out. Okay, what cancels out with the next fraction?
The x minus 1.
Mm-hmm. Which leaves us with?
8x.
Okay, what cancels out with the next one?
The x.
Mm-hmm. So we're going to have to multiply that out. And then what cancels out with the last one?
The x minus 1.
Mm-hmm. So now we're going to have to multiply out x, x plus 1. So this problem is a lot of work.
Mm-hmm.
Okay, so now we're going to FOIL. What do you get when you FOIL there?
You get x squared minus x minus 3x minus, or plus 3.
Good. And then we'll bring down the plus 8x. Okay, and then in the denominator, what do you get when you FOIL that out?
The denominator is going to be x squared minus 1.
The middle terms cancel out. Good. And then when you distribute the x?
X squared plus x.
Okay, we're still not even close to being done. Okay, so combine like terms in your numerator. What does that give you?
You got x squared plus 4x plus 3.
And in your denominator?
You have a 2x squared plus x minus 1.
Good. How would you factor your numerator? Because we're not done yet, because we have to factor to see if the factors cancel out. So we have gotten rid of the complex fraction, to be clear, but we haven't necessarily simplified.
Okay, so you would do the FOIL thing.
So what are two numbers that
factor
multiply to 3 and add up to 4?
3 and 1.
Good. And then for the denominator, I'm guessing you're going to want to do trial and error. So we're going to have a 2x and an x, and then we have to have 1s. So the only thing you really have to experiment with is the signs. There's not really a lot of options, which is good.
Is it -1, 2x minus 1, and then x plus 1?
X squared plus 2x minus x. Yep, very good. So does anything cancel out?
Yeah, the x plus 1.
Okay, so now we have x plus 3 over 2x minus 1. Can we simplify that further?
Nope.
No, so that is our answer. Very good. Okay, so why don't we try that same method on number 31? So if there's only two little fractions here, right? And you want to look at their denominators and you want to find the LCD. So what would be the LCD here?
X squared.
And this one I think works out a little bit better, hopefully. We'll find out. Or at least it might not be as long. Okay, so what happens here? When you multiply by x squared and then divide by x, what happens?
So you're going to get a 3x.
Good. Plus
7x squared.
All over?
Over 9. Minus 49x squared.
Okay, we got rid of the complex fraction, but are we fully done with the problem?
No.
No, we have to check and see. We have to see if it can be simplified, right? So we have to factor the numerator and denominator and see if they have any common factors. It could be that they don't, but it also could be that they do, like in the last problem. So we have to check. So what is the GCF for the numerator?
X.
Which leaves us with?
3 plus 7x.
Good. And then what can we do to factor the denominator?
You can do a 3 minus 7x and a 3 plus 7x.
Good. So does anything cancel out?
Yep, the 3 plus 7x does.
So what is our answer?
It's x over 3 minus 7x.
Very good.